Welcome to Algebra 1, Section 11.6, Direct and Inverse Variation. What is direct variation? Direct variation is any place that y equals kx, where k is a number called the constant of variation. You've seen y equals mx plus b, which is the equation for a line. So direct variation is anywhere where the slope is a constant, okay, you're used to that, but also that your b, your y-intercept, is equal to 0. So we can use direct variation to find our equation for the line and to determine further values that will fulfill the requirements. So in this case, we know that x and y vary directly, and we want to write an equation. Well, the form of our equation is y equals kx. We have a constant change. And we know that part's going to stay constant because it's called a constant change. So our y equals 8 and our x equals 2. When we go ahead and solve for the variable, we get 4 equals k. So it's going to change at a constant ratio of 4 to 1. Again, you can also look at this as a proportion. So we know our equation is y equals 4x. So for every x, we're going to have 4 y's. Inverse variation is the inverse of direct variation. It's y equals kx, where k is not equal to 0. K is still the number called the constant of variation. You may also see this as xy equals k. And that's simply if you multiply both sides by x, x's will cancel out on the right and becomes that equation. In this example, the variables x and y vary inversely. We can use this information to find our equation. Y equals k over x, where k is unequal to 0 is our equation. Our y is 5. Solve for the unknown. And so our equation is y equals 10 over x. You will also see this as xy equals 10. Here's another example. Since x and y vary inversely, we know the equation is y equals k over x. Fill in the values. 8 equals k over 1/2. To get the variable by itself, multiply both sides by 1/2. So we have 4 equals k. Our equation then is y equals 4 over x. You may also write this as xy equals 4. Here are the graphs of both direct variation and inverse variation. As we talked about in an earlier slide, direct variation is a line that starts at the origin and has a constant slope. And as you see, inverse variation is more like one that has an exponent. It curves. In this case, it has two, what you'll soon see are called asymptotes, at x equals 0 and at y equals 0. We'll talk more about those in another video. To graph either direct or inverse variation, you make a table just like we've done before. Put the values in for x, so 4 over 1 equals 4, so this point is 1, 4. 4 over 2 equals 2, so this point is 2, 2. 4 over 3 equals 4/3. This point is 3 4/3. 4 over 4 equals 1, so this point is 4, 1. Now you go ahead and sketch these on a graph. We have the point 1, 4, the point 2, 2, the point 3 4/3, which is slightly more than 1, it's 1 1/3, and the point 4, 1. So your graph is going to look like this, which is what we would expect for an inverse variation. Now you could have looked at this and realized that this is in the format already of an inverse variation. but then you miss out the fun of sketching a table and a graph. To determine if data is direct or inverse variation, we can either look for the equation or sketch the graph or do both. In this case, we're going to first sketch the graph and then we're going to look for the equation. We have the point 1, 2. We have the point 2, 1. We have the point 3 2/3. We have the point 4 1/2. And we have the point 10 1/5. So you can see the graph kind of looks like this, even through my sketch. So we can pretty much guess that's an inverse variation. Now to find the equation, pick any of the points and put them into this equation. So if you pick the point 1, 2, 2 equals k over 1. Well, that would signify that k would equal 2, right? Let's try the next one. One equals k divided by 2. Well, k would still equal 2. So I think that's probably our equation, but we can always check out a third one or a fourth one. So we have 2/3 equals k divided by 3. Well, again, it looks like k is equal to 2. So our equation is y equals our k value, which is 2 over x. Again, you may see this as xy equals 2. Let's look at one more example. Let's go ahead and graph this first. So we have 1, 5, 3, 15. 525 is way up here off our graph. 1050 is way off our graph. And 0.5, which is a half, and 2.5. It's a pretty good guess here that this is going to be a straight line. Okay. Go ahead and we can look at our equation. Since we know it's a straight line, we're going to use the direct equation. Stick in some values. 5 equals k times 1. Oh, that implies that k is equal to 5. 15 equals k times 3. Well, again, that implies that k equals 5. So 25 equals k times 5. Again, implies that k equals 5. So we can pretty much go with the fact that y equals 5x is our equation where k equals 5. Now, do I have to do all three checks? No, I don't. If I know it's a variation, it's either going to be direct or inverse. So I can go ahead and just do one or a couple of these. And that's how we find direct or inverse variation. See you in class tomorrow.